Imagine a world without metals, gases, or even the very air we breathe. A world where technology, medicine, and life as we know it simply wouldn't exist. It may sound like a dystopian nightmare, but this scenario reminds us of the foundational building blocks of our universe, the elements. These elements, each with its own unique properties and characteristics, come together to form the rich tapestry of matter that makes up everything around us. But how do we make sense of these countless elements? Enter the periodic table, a tool so powerful, it organizes the chaos of the universe into a coherent, understandable structure. Today, we'll embark on a journey through time and space, exploring the wonders of the periodic table and the elements that have shaped our world. The birth of the periodic table, our story begins in the mid-19th century, at a time when scientists were feverishly discovering new elements but struggling to find a way to organize them. The early attempts were primitive, with no clear understanding of the underlying relationships between elements. Then, in 1869, a brilliant Russian chemist named Dmitry Mendeleev changed everything. Mendeleev was not the first to try to organize the elements, but he was the first to do so in a way that made predictions about undiscovered elements. He arranged the known elements by atomic weight and grouped them by similar chemical properties, leaving gaps for elements that had yet to be discovered. Mendeleev's genius lay in his ability to see patterns where others saw only chaos. His periodic table was a revelation, providing a framework that not only classified elements but also foretold the existence and properties of elements that had not yet been found. Understanding the structure of the periodic table. At first glance, the periodic table might seem like a simple chart, but it's much more than that. It's a map of the building blocks of the universe, each row and column meticulously organized to reveal deep truths about the nature of matter. The elements are arranged in order of increasing atomic number, which represents the number of protons in an atom's nucleus. The rows, known as periods, correspond to the number of electron shells an atom has, while the columns, called groups, contain elements with similar chemical behaviors due to their valence electrons. One of the most fascinating aspects of the periodic table is how it highlights trends among the elements. For example, as you move from left to right across a period, the elements gradually change from metals to nonmetals. This is why, on the far left, you'll find the highly reactive alkali metals like sodium and potassium, while on the far right, the noble gases like helium and neon sit inert and unreactive. The elements that changed the world. Let's take a moment to explore some of the elements that have had the most profound impact on our world. Each of these elements tells a story of discovery, innovation, and transformation. Hydrogen, the simplest and most abundant. Hydrogen, the first element on the periodic table, is the most abundant substance in the universe. It's the fuel that powers the stars, including our sun. On Earth, hydrogen is a key component of water and organic molecules, making it essential for life as we know it. In recent years, hydrogen has gained attention as a potential clean energy source. Hydrogen fuel cells, which combine hydrogen with oxygen to produce electricity, offer a promising alternative to fossil fuels. The simplicity and abundance of hydrogen make it a cornerstone of both our past and our future. Carbon, the backbone of life. If there's one element that truly deserves the title element of life, it's carbon. Carbon's unique ability to form for stable bonds makes it incredibly versatile, allowing it to create a staggering variety of complex molecules. From the DNA in our cells to the fossil fuels that power our industries, carbon is at the heart of countless processes that sustain life and drive technological progress. Beyond its role in biology, carbon has also become a critical material in the form of graphite and diamonds. Graphene, a single layer of carbon atoms arranged in a hexagonal lattice, is one of the strongest and most conductive materials known, with potential applications in everything from electronics to medicine. Silicon, the engine of the digital age. Silicon, the second most abundant element in the Earth's crust, is the foundation of the digital revolution. Its semiconducting properties make it the perfect material for creating the transistors that power our computers, smartphones, and other electronic devices. The development of silicon-based technology has transformed the world in ways that were unimaginable just a few decades ago. Today, we live in a world where vast amounts of information can be processed and shared at lightning speed, all thanks to the remarkable properties of silicon. Oxygen, the breath of life. Oxygen is the element that makes life on Earth possible. It's the most abundant element in the Earth's crust and the second most abundant in the atmosphere. Oxygen is essential for respiration, the process by which organisms convert food into energy. But oxygen's importance extends beyond biology. It's also a key player in combustion, the chemical reaction that powers everything from engines to rockets. Oxygen's ability to support both life and technology makes it one of the most versatile and vital elements in the periodic table. Uranium. The power of the atom. Uranium is a heavy, radioactive element that has had a profound impact on the world, particularly in the 20th century. The discovery of nuclear fission, the process by which the nucleus of an atom splits, releasing a massive amount of energy, led to the development of nuclear power and weapons. While uranium's use in atomic bombs during World War II is a dark chapter in history, its role in providing nuclear energy is a testament to the dual-edged nature of scientific discovery. Today, uranium powers nuclear reactors that generate electricity for millions of people worldwide, highlighting both the potential and the peril of harnessing the power of the atom. The role of rare earth elements in modern technology. In the world of technology, certain elements play outsized roles despite their scarcity. Known as rare earth elements, these 17 elements are crucial for the production of high-tech devices, including smartphones, electric vehicles, and renewable energy systems. Neodymium, for example, is used to make powerful magnets found in wind turbines and hard drives. Europium is a key component of the red phosphors used in LED displays. Despite their name, rare earth elements are not particularly rare in the Earth's crust, but they are challenging to mine and refine, making them valuable commodities in the global market. The future of element discovery. The periodic table is a living document, constantly evolving as new elements are discovered and our understanding of the atomic world deepens. Since Mendeleev's time, scientists have added dozens of elements to the table, many of which were created in laboratories through the fusion of atomic nuclei. The quest for new elements is driven by both curiosity and the desire to push the boundaries of chemistry and physics. As researchers continue to probe the extremes of the periodic table, they may uncover new elements with unique properties, opening up possibilities for novel materials and technologies. The periodic table as a tool for innovation. The periodic table is not just a chart, it's a tool for innovation. By understanding the relationships between elements, scientists and engineers can design new materials with tailored properties, leading to breakthroughs in fields ranging from medicine to energy to electronics. For example, the development of new battery technologies relies heavily on the chemistry of lithium, cobalt, and other elements. Advances in superconductors, which can carry electricity with zero resistance, depend on the properties of elements like yttrium and barium. The periodic table provides the blueprint for these innovations, guiding researchers in their quest to harness the power of the elements. Conclusion. As we come to the end of our journey through the periodic table, it's clear that the elements are much more than just symbols on a chart. They are the building blocks of our world, each with its own story to tell. From the simplest atom of hydrogen to the complex structure of uranium, the elements have shaped the course of history and will continue to shape our future. The periodic table is a testament to the power of human curiosity and ingenuity. It represents our collective effort to understand the universe at its most fundamental level and to use that knowledge to improve our lives. As we look to the future, the periodic table will remain a vital tool in our exploration of the unknown, guiding us as we discover new elements, unlock new technologies, and continue our quest to understand the world around us.